All right, Assalamualaikum. We are live. Let's start off with today's class. So, in the last class, we ended our discussion on pixels, right? We looked into what pixels are, what screen resolution is basically, how your computer basically stores images in terms of binary, right? So, we had a pretty comprehensive discussion on all that. We had a look into colors and everything, such as like how does a specific pixel represent something, and so on. Inshallah, in today's class, we're going to be continuing from where we left. So, we were left with two important concepts. One was basically regarding the advantages and disadvantages of sampling, which was a minute part related to the sound topic, which was left earlier on. So, we need to first look into the drawbacks and the benefits. See? So, let me see if I have a space up here. Okay, we don't have space, but we need to make space for it. This is important, right? So, let me just remove this, and I want to paste this one table from the book, which is something really important. I want you guys to basically learn at least 2 points for the benefits part and 2 points for the drawbacks part. So, yes, so let me paste it up here. So, yeah, look into this table. This basically discusses the benefits and drawbacks of high sampling resolution. See, high sampling resolution. So, like, what benefits do you get if you have a high sampling resolution? What drawbacks do you have? So, we sort of have already discussed this, but we just need a quick recap too. So, an important point here to note is that your sampling resolution basically is the number of bits required per sample, say, so also known as bit depth. So, when you have a larger sampling resolution, this basically allows you to have a larger dynamic range. When I say larger dynamic range, it basically means this concept where I said that if you're making use of, let's say, 1 bit per sample, then you might have like let's say one specific column, or if I say one register for the whole sound, so like you can maximum have 4 bits per sample, which means that you could have 15 different values. But if I make it like 8 bits per sample, we can have 255 different values. So it can have your guitar, it can have your microphone, it could have your drums and all those other components, right? So it's going to improve the quality. So when we say that you have a larger dynamic range, it basically means this: कि आपके पास the capacity of having multiple volumes and sounds, that's pretty much very possible. So then definitely if I could have multiple instruments incorporated into one sound, it also means that the quality of that sound is going to be way more better. So the second benefit I get is basically having a better quality. And lastly, the biggest benefit is that if I have and let's say at this point the microphone which I'm using is of my laptop, right? But I'm planning on getting one externally. So now what's the difference between the external microphone which I will be getting inshallah and the one which I have right now? Even though both of them have the same usage, they have the same purpose, and the purpose of transferring my voice from my end to your end is already being achieved through both of them, right? So why should I go with the expensive one? The only benefit I get with an external microphone is that it allows my sound to have less distortion and it is way more clear. So this means that the microphone which I'm using right now, the one of my MacBook, it has a lower sampling resolution in comparison to that which I could set up externally. So this is the third benefit I get if I increase the sound resolution, that it allows my sound to have less distortion. But while I have these three benefits, there are also three drawbacks which you all should keep in mind. Firstly, definitely if you're having a greater number of bits per size per sample, this means that eventually the file that will be produced, it will also have a greater size because more bits are used per sample. Just like that, if you have like, let's say, if I have an audio file which is of 4 MB, downloading that will barely take a few seconds. But if I have it of like, let's say, 45, 450 MB, so that's a big number. Now for that, it might take like a few minutes. Now, the difference between a few seconds and a few minutes might not seem that big, but if I have to do it over a large album of, let's say, 100 and 200 songs, it's going to take a very long time. So, for that reason, the second drawback we get is that it takes longer to transmit, yeah, per download music files. Say. And finally, definitely, you might have heard this one thing that if a person is doing graphic designing, or maybe if he is composing some sort of audio, they usually get a proper computer for it, so which has a proper GPU and a proper components, which allows that the computer can regularly, efficiently, and ensure that the whole process is being done in a smooth way, right? So why is that required? Because all this process where you need to take this average even though this may seem very easy, where we are taking samples every after every set interval, This usually requires power. And so for that reason, if I want to do it for a larger sampling resolution file, it would require a lot of power. So the third point and the third drawback is that it requires greater processing power. Say, so this was one point which was left earlier on, and now we have basically looked into it in exam. They might ask you to tell us that, let's say Ramin is planning on getting a microphone which has a very great sampling resolution. List down two drawbacks of this decision. So you should be aware of at least two drawbacks and at least two benefits. This is my advice. तीन कर दो best, otherwise दो होने चाहिए. सही. Now coming back to where we were, we basically looked into screen resolution. We saw what pixels are. We had a look at the advantages and disadvantages of sampling, and now we are going to be basically discussing bitmap images. So you might have heard the word bitmap images. Now, bitmap images hota kya? Bitmap images, like the way I say that if there is something containing my sound, I call it an audio file, right? Or an MP3 file. Or if something has like a video in it, I call it an MP4 video, something like that. So an image which is basically made up of pixels is known as a bitmap image. So if ever in exam they ask you to define bitmap image, तो आपको बस इतना पता होना चाहिए bitmap image refers to an image created through pixels. Now you might be wondering, sir, क्या मतलब? Do we have another sort of image जो कि pixel से नहीं बनती? Yes, there is one other type of image जिसके अंदर they do not use pixels, they use the geometric shapes, but that's not discussed at your level. That is something which if you plan on taking A level computer science to AS में, you're going to be studying vector images. सही है? And so for now, just know that if in exam they ask you to define bitmap images, so bitmap images are basically those images which refer to the one which are basically created through pixels, or I can also call it as that bitmap images are made up of pixel. And usually these pixels have a big value. So yes, so when I say that there is a specific number of pixels used per image, or like let's say मैं बोल देता हूँ कि every, like I told you this in the last class too, that each pixel, that small box on the screen, is having a different binary value, right? So this means that all of my bitmap images, basically all these small boxes, like you see all these small boxes having individual binary combined, right? So this has a binary, 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 and all of them are basically combined together to formulate one final sort of line which shows all the possible binary values of that image. So now when my computer has to deal with it, it now understands, okay, 1100, this was for the red part of that image, 11010, this was for the next blue box only image. And so when you kind of combine all of these multiple binary and these boxes, it's going to result in the image which we had at the first place, right? So this means that all these binary values, pixels, have some sort of value. Now, at this point, there is one term जो कि आप लोगों को पता होना चाहिए, and that basically refers to color depth. So just like before, like a question can come upon what's color depth. So you need to basically define color depth. And color depth is sort of very similar to your sampling resolution because it refers to the number of bits used to represent each color. The number of bits used to represent each color. Now you might be wondering, okay, I get that. ये तो बड़ी straightforward बात है. But what do we mean by this statement, number of bits used to represent each color? Isn't it like if I have to represent green, it's going to be having only the binary, it's going to take just one bit. If I have to represent red, it should also have one bit, and so on. But in reality, there's a big difference. So ये होता ये है that when I create a pixel, let's say I have a screen up here, okay, I have this one monitor, and on this monitor, let's say I divide it into two parts. So like I have two pixels, right? I have two pixels, one this and one this. Now when I have this two number of boxes, I can basically say that, let's say अगर मैं ये बोल देता हूँ let's say I have only two boxes and I want to represent two colors. Let's say I want to represent one of them as black and the other one as white. So an image where I only require two possible colors, one being black and the other being white, I only need two possible, like I only require two colors, right? Just a minute, let me just fill this and then फिर आपको सही समझ आ जाएगी. Just give me a minute. Do we have black? Oh yes, we do. That's great. Let me get the black color. So let me fill this. So let's say how many colors do we have up here? We have only two colors, right? So if I have to solve a question where they tell me, bro, that I want to figure out the color depth or the number of bits I would be required to have to store just two possible colors, what would be that number? So for that there is this one easy way कि यार देखो जो हमें ऊपर आप लोग को ये बता रहा हूँ कि pixels या फिर the number of bits used to represent each color, this basically indicates and it tells us that if I have more number of bits used for a specific pixel, this means I can represent greater possible colors. How? Like if I say 2 raised to power 1, because eventually everything is in terms of binary, right? So the base is going to be 2, but 2 raised to power 1 is basically 2. This means that if I'm using 1 bit per color or 1 bit per pixel, I can only represent maximum 2 colors, which in this case are only going to be white and black. So two possible colors. But let's say I increase, I say, okay, no, I would be having 3 bits per pixel or per color. This means now I can have 8 colors. And now these 8 colors could represent stuff like, let's say, क्या कहते हैं, we can say it might represent red, green, blue. Let's say, see, red, green, blue. It might also include the other components. And just like that, if I say 2 raised to power 8, now it could represent 255 colors. So you would have noted one thing, that the number of bits, when I increase the number of bits, like from 1 to 3 and from 3 to 8, the only change occurring is that basically my possible colors which I could represent on my screen, they are increasing. So like originally, if I was only making use of 1 bit, the only color which my screen could have was either a black or a white color. So it could have been both black or both could have been white or a mixture of two. But now if I increased it from 1 bit to like let's say 3 bit, now I could represent multiple colors. Now like, let's say यहाँ पे black और वो तो हो ही सकता है, but now I could also come up with let's say one color to be red and the other could be green, and like let's say we could have a black up here and so on, right? So we could have multiple colors being mixed. And so this is how and why we have these color image TVs. So like originally when we had like those older TVs which were black and white, they did not have the color depth to an extent where it could represent multiple colors. So back then the older TVs only had 1 bit used per color. Say so the color depth was of basically 1 bit. So older TVs like the one like this, those square TVs, like those black and white, they had a color depth of 1 bit, which basically indicated that how many possible colors can it represent? It can basically represent 2 raised to power 1. So it could have maximum 2 colors. And we are well aware that those 2 colors are basically black and white. But now over the time, computer scientists, what they did was they tried to figure out how they can increase the color depth. Now we don't have to study what's the logic behind that, but just for your own sake, you should know that basically scientists were successful in increasing the color depth of a screen. And so when they increase this, what do we call it, the number of bits used to represent each color, and or if I say they increase the color depth, you observe that now the screen originally had like 2 colors, but now they can represent up to 8 colors. And so with every passing day, you might have seen that, okay, pehle hamare paas the HD TVs, then came up those full HD TVs, then we had 2K, okay, and then came up 4K, and ab aage 4K QLED tha, and now we have 8K coming up. Now, what's the difference in all of them? Apart from the way it's being monitored and the way it's being fitted in your TV, the biggest difference lies in the fact that with every newer technology, the number of bits used to represent each color are basically increasing. So we can say that the color depth is increasing, which allows it to have a greater range of colors. So now if I have only 8 colors, I might be only representing one single shade of red, like only this color red, jo ki hai. But we don't have only one color of red, right? We have multiple shades of red, like maroon red, we might have apple red, we might have green red, greenish red, we might have like a yellowish tinted red or something like that. So now when you increase the number of bits, it allows you to not only represent the basic colors, but it also gives you the possibility to represent the different shades of each color, which eventually allows you to have an even more realistic image. So for that reason, the important point here to note is that when you increase the color depth, when you increase the color depth, it allows you to have a better quality. So your quality also improves. Why? Because more colors could be represented. So more colors. Now definitely कहाँ पे एक color से एक पूरी image बनाना है, where you have like let's say thousands of color pencils. So now in this point, an important point here to note is that if I tell you that okay, Ramin, you tell me that if a specific file uses a color depth of 5 bits, okay, how many colors can the document contain? Can the document or yeah, can the file contain? Now this isn't a question which an examiner tests, but आपके अपने understanding के लिए you should know. 32, perfect, really good. How did we get the answer 32? Because we understood कि यार एक डब्बा on the screen is basically representing one binary, and binary has the power 2, right? So base 2. So 2 raised to power the number of bits, which is 5. So 2 raised to power 5 is basically 32 colors. So you should be aware of this. And even though मैं यहाँ पे आप लोग के लिए formula लिख भी देता हूँ, the formula is 2 raised to power x, where your x is equal to number of bits, or I can say color depth. दोनों में से जो आपको सूट करते हैं. Say, so if ever in exam they give you a question to tell us how many colors this file might contain, you should look for the color depth, because the formula is just going to be 2 raised to power whatever that thingy is. So that is the important point you all should be aware of. उसके बगैर बस यही point है कि just like before, when you increase the color depth, the quality is going to increase because we have more colors. But the only drawback is that it's also going to increase your file size. So it would also increases file size. And just like the same point of view which we discussed earlier on for the sound wala, when we increase the file size, it has a few drawbacks, that it's going to take longer to transmit, and it might have the problem of let's say if I want to, let's say, share it with someone, it might not be done quickly, it might take extra time. The same general point जो हमने पहले पढ़ा है. Apart from that, it might be occupying greater space on your computer, and definitely if you are having a larger color depth, this also means that it's going to require a greater processing power. So yeah, now we have basically looked into the general concept of the whole image part. We are done with this. So, yeah, so for your knowledge, you all just need to be aware of all this stuff. We just need to look into now how does a computer store files. And once we understand that, uske baad we are going to be looking into how when you add a specific image into the document, let's say you are making a presentation and you copy an image from Google Chrome and paste it in there, and then you want to see कि यार इसके file size पे क्यों impact बना है, तो how are you going to calculate the file size for a specific image or for a specific character or maybe something like a specific sound? ये कैसे करना है? For that, there are a few formulas and thingies which we are going to be studying inshallah. But before looking into that, it's important आपको ये तो समझ आ जाए कि how does a computer store data. So we are now, inshallah, starting off with chapter number 1.3, which is basically discussing data storage. But before moving on, Ramin, could you kindly confirm, is this totally clear, or do you have any questions regarding the course content? क्योंकि अगर है तो पूछ लो. It's really important. Say. Perfect. That's great to know. Okay. So now let's start off with computers. Now we studied earlier on that your computer basically is working upon a model where it is storing values. And we saw that the computer basically stores all its value in terms of binary. So it is basically storing 0 and 1s. But your whole computer doesn't operate in a way where one single one could represent, like, let's say, a specific function, right? That's not possible. We have multiple 0, 1, 1, 0, 1, 1, 0, 1, 1, 0, and this might represent something, like this might be some number. And just like that, if this something is representing a number, imagine if I have a specific large executionary task, how long would that binary file length would be, right? It's going to take hundreds and maybe thousands of zeros and ones. Now, where does your computer store all this? Okay, that's great to know. That's great to know, Ramin. So now, how does a computer store all this? Now, for that reason, we have to basically look into the topic data storage, where we're going to be observing कि आपके computer में data store कैसे होता है. So now, when we were starting chapter number 1, we studied the concept of register, right? We studied how a register is a box like this, which can basically store a data. Now, in your register, this one box is basically, you can say that this has to be the smallest slot within your computer memory. Like this could either have the value 1 or this could have the value 0. इसको further divide नहीं कर सकते. So I cannot divide this one box into a very further smaller part, because we have studied already that binary is basically the atom in chemistry, right? So we cannot divide binary further. So हम ये बोल देते हैं कि if I'm storing binary in this one small chunk of a register, this has to be the smallest memory slot, right? The smallest memory slot. So when I call this as the smallest memory slot, this thing in terms of computer is basically known as a bit. So your bit is the smallest memory, smallest memory, is the smallest memory क्या बोलेंगे? It's basically the smallest memory storage term बोलो, smallest memory storage term. Say, so if you ask कि यार कितने, what do we call it, what's the smallest memory storage file in your computer, or what's the most smallest possible term used to denote the most smallest thingy out there in your computer, तो आपको पता होना चाहिए that is basically a bit. There is nothing smaller than a bit in your computer. Now comes the funny part. Now, till now, we were basically looking into 8-bit register. Remember, हम क्या बोलते थे? 8-bit register. So like I had 1, 2, 3, 4, 5, 6. Oh, उल्टे पुल्टे बन गए. 1, 2, 3, 4, 5, 6, 7, and let's say 8. So now this is basically an 8-bit register. 8-bit register. Now the point here to note is usually 8-bit was something जो कि मैं शुरू से बताता आ रहा था, 8-bit, 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 but there was a logic to it too. Why does the computer programmer love discussing 8-bit again and again? Because 8 bits is basically equal to 1 byte. Now in your computers, you might have seen that if there is a small file, it might be written as 23 bytes. Now, what does this 23 bytes mean? This basically means that it has how many bits? It has basically 23 into 8 bits. So the important formula here to note is, let me even put a star up here, that your 8 bits basically equal to 1 byte. This is a bit different. Why? Because इसके बाद जो आएंगे ना, from byte to kilobyte and kilobyte to megabyte, that has 1,000 wali form. But right now, this bits wali only has 8 bit to 1 byte, which is something a lot of students usually mess up. So आपको यहाँ पे ये पता होना चाहिए कि 1 byte is basically equal to 8 bits. But even 1 byte is not that big of a deal. Why? Because even if I do 23 into 8 from my calculator, you would have observed, एक second, 23 into 8 is basically 184. So you have basically 184 bits. Now you tell me 184 might be only used to represent a big number. Like let's say if I want the computer to write the big number 1, 2, 3, 4, 5, 9, 8, 7, 6. Now this is a very big number. If I want to represent it in a register, it might occupy such a big space. And even if not, चलो ये मैं थोड़ा exaggerate भी अगर कर रहा हूँ, 184 bits might only be using a specific chunk to represent a very big value, let's say. But now you tell me your computer has so much advanced functions, it has to deal with such big things. Do you think even this one image which I might be taking, like let's say if I show you one image on my phone, it might have a greater file size from it. So let's say I have this one image, and let me see if I could yeah, up here, and I hope I can see. Yeah. So look up here. This is one image I took that day, okay? And in this, you might be able to see यहाँ पे किधर लिखा हुआ था. Yeah. You see, if you look up here, it's clearly written 653 kilobytes. Kilobyte, it's not byte, it's like kilobyte. अब kilobyte क्या उसके ऊपर आता हो. But this means that one image is basically occupying such a large space. This is basically because our number of bits or 1 byte is not enough to store all of that data. And so if I have to, let's say, represent a very big file, so like this file might have been 657,000 bytes. So अब इस तरह लिखना बहुत मुश्किल हो गया था. So what computer scientists did was that they tried to introduce a new term, and they were like, bro, let's say if we have 1,000 bytes, we are going to call that 1 kilobyte. And this 1 kilobyte is basically known as 1 KB. So now when you were dealing with computers memory, you might have seen the word KB. This KB refers to kilobyte. And now if a question comes up saying that there is a file having 3 KB, this means it has basically 3000 bytes. And if I have to convert that 3 KB into bits, then I would do it like 3000 multiplied by 8, which means 24,000 bits. समझ गए? Just like that, when we had 1 kilobyte, 1 kilobyte was still not enough. Like the image I just showed you, it has like 657 kilobytes. Now, what if I have a big file like 15,000 kilobyte? Writing 15,000 kilobyte is not that convenient, right? So what computer scientists were doing, they thought, let's introduce a newer stage. And if we have, let's say, 1,000 kilobytes, that's going to be known as 1 megabyte or 1 MB. Now, a lot of your games and files are basically in 1 MB form. So you might say if you're using a phone and you're downloading, let's say Instagram, it might say 570 MB. So this MB basically refers to megabyte, which means that if I have a 570 MB file, it has 570 multiplied by 1000 itne bytes and then multiply by 8 to find itne bits. So just imagine if an Instagram file has this many bits, a whole computer processor might require so much more, right? Now, this is just like a small example, but now we have seen a big game like RDR2, which is Red Dead Redemption 2. When you try to download it, it might be of 67 GB or like maybe 70 GB, let's say, if we round it up, right? 70 GB. Now, if we have it of 70 GB, that's a very big file. That's a very big file. And now we aren't using MBs. We introduced a newer form and we were like, okay, let's say that if we have 1000 MBs, that is basically going to get into 1 gigabyte, or I can say 1 GB. Now you all are required to know, okay, yaar, 1000 bytes is going to make 1 kilobyte, 1000 kilobyte is going to make 1 megabyte and all this. Now remember at the start, I was referring to one thing, कि usually students mess this part. They do usually confuse it कि यार 8 bits 1 byte बनता है. So do keep this in your mind. ये ना कर देना कि 1 byte is equal to 10 bits based upon the logic being used beneath it. This is a special exception. You should be aware that 8 bits is going to make 1 byte, and then after that it's like 1000, 1000, 1000. And do you know, at this point, even though you might look into 1 GB and all that stuff, but your computer hardwares are basically like 1 TB or like 2 TB. Like if you go and get yourself Google Gemini Pro version, you get 2 TB of free storage. Now, what's 2 TB? Just sorry for that, yaar. 2 TB. Now, what's 2 TB? TB basically refers to a newer form, and it's basically when you say 1000 GB is combined to basically form 1 terabyte. And terabyte usually refers to TB, 1 TB. So if I say that I have a hard drive, which answer, oh, yes, Ramin, thank you for figuring that out. I missed that point. उस पे आता हूँ. Yes, thank you for missing that. Missing बोल रहा हूँ. Thank you for telling that. Say, so if I have 1000 GB, that basically means I have 1 terabyte. So if I say that I have 2 terabyte hard drive, this means I have 2000 GB. But now it's not stopping at 1 TB. Now, like these big servers, they have even more data than that. And so if I have a big server like the Google server, which is basically storing all our data on their servers, like everything, like from my what do we call it, passwords and files, all the way to my Google photo images, and everything is being stored on external servers, right? So it's not only for me, it's like for all the users. So अब वो तो बहुत बड़ी चीज है ना. So for that, the computer scientists were like, okay, let's also assume if we have 1000 TB, let's make and call that 1 petabyte. So 1 petabyte or 1 PB is basically known as 1000 terabytes. Now, one convention which I missed earlier on, thanks to Ramin, just to point out kar diya, was basically that when you have 4 bits, that's going to make 1 nibble. And now, if you remember, when we were discussing chapter number 1, he hexadecimal one part, I said that we are basically going to be making groups of 4. Remember when we were converting, I was like, aapne char ke groups bana de, 1, 2, 3, 4. 1, 2, 3, 4, and then we're going to divide each of them separately. Now, I didn't want to use this convention back then, but usually it's like aapne nibbles bana dene. Now, when we say that you need to divide this whole register into nibbles, this basically means you need to divide them into 4 bits, which mean that I can make one as this, 1, 2, 3, 4. This is 1 nibble, and then I can convert this into the other part. This could be my different nibble, 1, 2, 3, 4. This could be my second nibble. So this different separate 4 bits one apart is known as nibble. So we can also say that 2 nibbles basically make 1 byte. because two nibbles are basically 8 bits, and then 8 bits is basically 1 byte. So now this convention is something जो कि आपको याद होनी चाहिए. In exam they might ask you what's the smallest possible memory slot, so it's a bit. After bit, it's your nibble. After nibble, it's your byte, and then kilobyte, megabyte, gigabyte, terabyte, petabyte, and so on. See, now for your information, you just need to know till petabyte. इससे आगे आपको पता नहीं होना चाहिए. But now there is one problem, in reality, we up here are assuming that okay, one problem exists, and the problem is, sir, we computer, right, like the computer operates on binary, right? The computer operates on binary, and binary only has two possible states, 2 raised to power something, right? 2 raised to power x. इस तरह के फॉर्म में ऑपरेट करते हैं, राइट? लाइक वी सॉ 2 raised to power 0 1 2 4 8 16. So like up here this was 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 4 5 6 7 8, and it all went in terms of 2 raised to power. So this means that if I want to store 1 byte, or maybe if I want to store 1 megabyte, all that memory slot also has to go in the same format. Like इसी चीज को मैं extend कर रहा हूँ ना, like यहाँ पे 2 raised to power 8 है, this might go on 2 raised to power 16, 2 raised to power 20, 2 raised to power 30, and so on. But it's going in terms of 2 raised to power something. Now the problem here was that your 1000 thingy, this does not come from 2 raised to power something. So it's like 10 raised to power 10 raised to power, let's say if I say 10 raised to power क्या कहते हैं 10 raised to power 10, so that's basically equal to 1000. Or if I say 10 raised to power 20, this might be equal to some other form, like let's say 10 1 0 0 0 0 0 0. So now if I say that I want to represent 1000 MB, 1000 MB is basically 100,000, like 10 lakh basically bytes, right? Kilobytes, sorry. So 10 lakh kilobytes is basically equal to 1000 MB. इसी तरह ना. Now the problem was हमारा computer तो 10 raised to power के form में चलता ही नहीं है. It operates in the format followed by 2 raised to power something. So this convention which we had up here, this was following the 10 raised to power wala convention. It's not following the 2 raised to power wali convention. Now this was a big issue because your computer does not understand 10 raised to power wali logic. It only understands 2 raised to power wali logic. And for that reason, because the memory size is actually measured in terms of power 2, a newer convention was basically introduced by the IEC. Now you do not need to know this, but a newer convention was introduced, and was introduced because of what reason? Because of the fact that your memory, or basically the size of the memory, it is because the size of the memory is actually measured in power 2. So because we have only power 2 raised to power something, like 2 raised to power 1, 2 raised to power 2, 4 6 8, and now this might continue, right? 2 raised to power 10, 2 raised to power 20, 2 raised to power 30. So now if I do 2 raised to power 10, 2 raised to power 10, it's not going to give me 1000, it's going to give me 1024. See, if I do 2000 raised to power 20, it won't give me 1 lakh, it might give me 1048 and some like 756, if I'm not wrong, some digits like this. See, अब ये क्या हो रहा है? It's giving me a different answer than this one and this one. These are two different values. अब आपका computer कौन सा store करता है? This. Because computer follows the binary form, this is your actual computer value. So because it follows that, this is the value which your computer is storing actually. But because this is going to make the calculations very challenging, क्योंकि आप मुझे बताओ, if you have to divide 1048756 with, let's say, some number, it might make the calculation really challenging. And so for that reason, this other number system was introduced just for your ease. But now because examiners do not want your ease, what they did was that before 2023, like in 2021, 2022, and all those previous examinations, there was no concept of this new convention. But because now students were thinking that, let's say I have 1 GB, 1 GB basically means that I have 1000 MB. That's not true. That's not true. So in computers, originally people came up to, like, for instance, I too was thinking that if I have 1 GB on my computer, this is basically equal to 1000 MB. But in reality, this is false. This is not true. This is false. And what's the real part? The real part is that if I say that I have 1 GB on my computer, this basically means that I have 1024 MB, because it's 2 raised to power 10, not 10 raised to power 10. Say that's the difference. And now this is basically true. This is basically true. And for that reason, आपको ये पता होना चाहिए कि when I say कि a computer has a 1 GB, it basically has 1024 megabits. But now you might be wondering, sir, अब आपने तो ऊपर वाला भी पढ़ लिया है, and now you're saying 1 GB, ऊपर तो 1 GB was basically 1000 MB. यहाँ पे आप बोल रहे हैं 1 GB is 1024 MB. How will I be differentiating in this? Now that's a valid question, you know. And for that reason, what computer scientists did was they said that, okay, let's keep the normal one there too, which is basically dealing in terms of denary value. Let's introduce a newer one, which we are going to call as the IEC number system. And we're going to change the name of the bits slightly. थोड़ा सा हम उनके नामों को update कर देंगे. So rather than saying, okay, we have 4 bits. Now this part is same. So it's basically the same. We have 4 bits equal to a 1 nibble, because we know that this is 2 raised to power 2, right? And then now if I say 8 bits, which is again 2 raised to power 3, right? This is going to be 1 byte. But now comes the fun part. Now when I say that I have 8 bits, उसके बाद की logic ये कि if I have, let's say, 1 TB, what do we call it, 1024 bits, bytes, 1024 bytes, this won't be equaling 1 kilobyte. So I won't say 1 kilobyte. Why? Because ऊपर तो हमने ये देख लिया कि 1 kilobyte is 1000 bytes. Now to alter it slightly so that we can differentiate among them, we're going to call this 1 kibibyte, 1 kibibyte. So rather than it being kilobyte, it's now kibibyte. And in notation, it's written like KIB rather than the actual KB. Say, so now in your computer science, it's important that you know this notation. Even if your software or whatever is writing it KB, you should know that your memory basically operates in KIB form. Say, so uske liye to ye कि 1024 bytes are basically resulting in 1 kibibyte. And now this is going to continue, and it's going to be like, okay, now if I have 1024 kibibytes, that's going to equal 1 MB byte, and that would be represented as MIB. And not just like that, if I have 1024 MB bytes, that's going to be equal to 1 gigi, what do you call, not gigi, GB byte, 1 GB byte, GB, GB, GKI के साथ नहीं चाहिए, 1 GB byte, 1 GB byte. And this 1 GB byte would be represented as GIB. And just like that, if I have 1024 GB byte, it's going to be it's basically going to get equal to 1 TB byte. So it's like 1 terabyte को हम TB byte बोल रहे, TB byte. And again, the notation would be TIB. And finally, when I have, let's say, 1024 TB byte, it's going to be equal to 1 TB byte. Say TB byte. And if you want to extend it even more, एक step आप और भी आगे जाना चाहते हो for both of them, so 1024 PB byte is basically going to equal to 1 XB byte, or I can say 1 exabyte for the earlier one. अब अभी तक की 1 exabyte और इसकी वो इतनी है नहीं, but still because it was there in your book, it's also something अगर आप लोग सीखना चाहते हो तो कर लो. So ये 1000 petabyte is basically going to be equal to 1 exabyte. See, and just like that, if I say I have 1024 PB bytes, say, so PIB, if I have PB bytes and I want to equate it, it's going to be basically XB byte. And now if I have to basically write this in terms of binary, इस तरह का एक क्वेश्चन आई गेस आई हैव सीन, इफ आई हैव टू राइट दिस इन टर्म्स ऑफ बाइनरी, तो आपको बस इतना पता होना चाहिए कि व्हेन आई से दैट 1024 इज इक्वल टू 1 KB byte, दिस मींस दैट आई एम रेफरिंग टू 2 raised to power 10. 2 raised to power 10 is what? 1024. So ये आपको थोड़ी स्लाइड से नोटेशन आइडिया होना चाहिए, because in I guess when I was preparing there was one question like this which I have seen, जिसके अंदर they clearly said कि okay, what is 1024 bytes in terms of binary notation? तो आपको ये पता होना चाहिए. And now the funny and the easy part up here is that you don't need to worry कि अब ये मैं याद कैसे करूँगा. Why? Because this is literally just increasing the power of 10 by 10. How? Now the next one is going to be 2 raised to power 20. And then this one is going to become 2 raised to power 30, and then this would be 2 raised to power 40, and then this would be 2 raised to power 50, and finally this would be 2 raised to power 60. Now just imagine 2 raised to power 60 means 2 and then up to like 60 boxes. 1, 2, 4, 8, 16, 32, and like so many big file, right? Like it can store such a big file, such big values and all that. And just like this, up here is basically 10 raised to power 10, 10 raised to power 20, 10 raised to power 30, 10 raised to power 40, 10 raised to power 50. इट्स नॉट समथिंग जो कि एक्सप्लिसिटली आपसे टेस्ट होगा, बट इट्स समथिंग आप अपने जहन में रख लेना, बिकॉज एग्जामिनर को कुछ पता नहीं लगता. इफ दे गिव यू अ क्वेश्चन लाइक दिस, यू शुड बी अवेयर ऑफ सॉल्विंग इट. सही है. Now we are done with basically the general methods of storing data. Before moving on, can you guys kindly confirm आपको ये अच्छे से समझ आई है, like all this, what's the difference between kibibyte and kilobyte? Why does the computer only get kibibyte and not kilobyte? This is really important because your computer uses what? Binary, and your binary is in terms of base 2, so ये 2 raised to power की form में होना चाहिए, not in terms of 10 raised to power 10, 10 raised to power 20. So it's really important आपको ये logic भी पता हो. Usually in schools, teacher just tell the kids that the computer is making use of 2 raised to power something. They don't explain why we are having IEC. Like really when I was preparing back then, मुझे तो समझ ही नहीं आ रही थी कि यार whether I have to memorize this one या that one. So for that, it's also important that आप अपने question को गौर से देखो. Now in your exam, if they write the word that, let's say, X person has a file of 5 kibibyte, तो आपने समझ जाना है कि this is basically referring to 1024 bytes. And at the same time, it says that Y has a file of 50 MB. So now it's not megabyte, it's megabyte. So now it's basically referring to 550, है ना, तो 50,000 kilobytes. So these two are really different. इसमें गलती नहीं करनी. When it says MB, and MB is basically the conventional normal stuff, so you need to write and solve the question in terms of the normal data type. But usually if they give you in terms of the IC format, तो आपकी values and the calculation are also going to be including the IC number system. So it's going to include the bytes, it's going to include the KB bytes, it's going to include the PB bytes and all that stuff. So we're going to be inshallah doing multiple questions regarding this. You don't need to worry. But now we're going to be looking into the formula of how to calculate a file size. But before moving on, Ramin, could you kindly confirm, did you understand what we are basically trying to say up here when I'm discussing these two number system, data storage systems? What's the difference between them? How are they similar? How are they different in terms of the basis? And what's the difference between their naming terminology? So it's basically same name here, but they just include a small new part like kilobyte se kibibyte, megabyte se megabyte, from gigabyte to like gigabyte, and so on. So it's pretty similar. You just need to reiterate it a few times, and inshallah, it's going to get there into your memory. Now, before moving on, can you kindly confirm ये अच्छे से समझ आ गई या नहीं? Or if you have any questions, just ask off, because this is, sir, do you have to memorize all these conversions? You need to memorize, you should be aware of basically the names. So you should be aware of all the names. Okay, like what is 1 kibibyte, what is 1 megabyte, and you should be aware that 1 kibibyte is equal to 1024 bytes. One, what do we call it? Megabyte is basically equal to 1000 kibibytes. 1 terabyte is basically equal to 1024 gigabytes. And just like that, you should be aware, like if I give you a question 1 gigabyte and ask you to convert this into, let's say, number of bits, तो आपको ये आना चाहिए how to convert from gigabyte to bits, or maybe go from bits to gigabyte. So the conversion between these data types is something which you all should be aware of, and it's pretty easy. Like, right, if I tell you that there is a file is of, let's say, 50 MB, and I need to convert this 50 MB, like let's do a bit of practice, 50 MB, and I want to convert this into bits. How will I be doing this? So originally I have MB, right? So I'll be going from MB to KB, and then from KB I would be going to B bytes, and then from bytes I'm going to go to bits. So let's just apply the formula. I have 50, and 1 MB basically has 1000 KB. So I'll be multiplying this with 1000. Then 1000, 1 KB basically equals 1000 byte, right? So I would be getting this. And basically, because 1 byte equals to 8 bits, finally I would be multiplying this with 8. So my answer is going to be 50 into 8 is 5 8s are 40. So it's going to be 400 followed by 3 zeros ye ho jayenge, and then 3 zeros ye ho jayenge. So this many bits basically exist in a 50 MB file. So just like that, you should be able to perform calculations, because in exam there will be questions asking you that there is a file and you need to give answer in this specific format. So you need to basically multiply here and there. But once we do those questions, you're going to understand it's not that difficult. It's pretty straightforward. But now before ending the class, we have the last 10 minutes. I would like to just discuss the formula of the image, how to calculate the size of a file, and then we're going to be ending the class tomorrow. Inshallah, in our next class, we're going to be basically starting from some past paper questions. We're going to look into some past paper questions so that you all are fully prepared to ace the exams. कि exam में कैसे test होगा सही. So calculating file size. Please note that no formulas would be given in exams. So except for some common thing, except for like some exceptionary cases where they have clearly mentioned that you do not need to memorize it. So if a scenario like this comes up in exam, तो उसमें उस सूरत में आपको given होगा formula. Otherwise, you should be able to calculate the file size at any point, say, or use any sort of formula in their book. So the formula basically is that your size is equal to image resolution into color depth. Image resolution into color depth. And color depth किस format में? Now the units are also important. So you should be aware that your image resolution should be in pixels and your color depth should be in bits. In bits, and this should be in pixel. This is basically equal to size of file. Now, let's do a quick question. Let's say there is an image which has the resolution 100 by 230 and it is making use of a color depth of, let's say, 3 bytes. Calculate the file size. So you're just going to plug in the values because we want to find the total image resolution. The total resolution find karne ka tarika ye, you multiply the value, right? So it's basically going to be 100 multiplied by 230. And then you need to multiply it with your color depth. But the important and the most confusing point, which a lot of students usually miss, is that you see my color depth here is in bytes, but you need to give your color depth in terms of bits. So we need to convert this byte into bits to be used up here. And because we know 1 byte is basically equal to 8 bits, so we need to convert this 3 bytes into bits first. Just easy tarika ye hai ki you do multiply by 3 and then you multiply that by 8, because 3 bytes is basically 8 into 3, or I can say 24 bits. So I could directly plug in 24 and I could multiply that with 8. And now this would get me the answer in 24 into, let's say, 2300. And now I have to multiply this now because I don't have a calculator, and is tarah ki usually questions straightforward hi aate. But if a question like this comes up, you would be doing it like this and aapke paas answer aa jayega 552000, because this was a made up question. You won't be asked to deal with questions where you need to change and do such complex sort of calculations. Usually it's going to be very direct, like 20 into 20,000, so that's 46,000, see. So stuff like that, 4,60,000, my bad. So stuff like that. And now you tell me ye jo answer hai ye iska kya unit hoga. So the unit of this specific answer is basically bits. Why? Because when I was doing this, your screen resolution, this does not have any unit. So yeah, this is basically pixel. So pixel ke saath hum deal nahi kar rahe, it's useless. Again, this number of 3 multiplied by 8, this is going to give me the color depth in terms of bits. So for that reason, this answer is also going to be in bits. Now, if I want to convert this answer into, let's say, megabytes, so how will I be doing this? I'll have like 552000. I would be dividing this firstly because it's by bits, right? So bits. So bits se main jab byte mein jaunga, what will I be doing? I'll be first dividing this by 8. Okay. And then jab main isko 8 se divide kar lu, again, these complex questions would not be there, but it's going to result in 69,000. And now this means that it has 69,000 bytes. And now if I want to go from bytes to kilobytes, I would be dividing this again with 1,000. So when I divide it again with 1,000, I'm going to get 69 kilobytes. And now if I want to convert this into megabytes, MB, I will be again dividing 69 by 1,000. And you're going to note that my answer to this question is basically 0.069 MB. And so in this case, you are going to be writing this as the final answer. Now, you might have observed that I was making use of the calculator, right? But in exam, the question would be very straightforward. That would not be requiring the calculator. So once we do those past paper questions, aap observe karoge, it's not that complex. It's literally very straightforward. And now because the question up here asked me to give the answer in megabytes. Like, see, I said that give me answer in megabytes. I was dividing it with 1000. But if the question stated that, bro, you need to give me the answer in megabyte, so us scenario mein I would have been dividing this by 1024 rather than 1000. And so this would have gone up, and फिर मेरे पास जो भी answer होगा, that would have been again divided by 1024 to get my final answer. But उसकी भी एक shortcut है, you don't need to worry as to how you're going to divide by 1024. वो तो काफी complex हो जाएगा without calculator. But we're going to do that once we get a proper question to it, and you're going to understand that it's not that difficult at all. With that, we are going to be basically also discussing one other formula, which is basically calculating sound file size. Calculating sound file size. Now, I haven't seen a lot of questions on sound file size, wala, but the formula is there in the book, and I guess it has been tested a few times. So you should be aware of the formula and should do a few questions. Inshallah, hum kal iske koi question dekh lenge, and we're going to do those, inshallah. So the formula to that is you have the sample rate, which will be given in the question. So like sample rate of 10 hertz or whatever in hertz. So the unit is important, and this value would be given in the question. Say, then you have basically multiplying this with your sample resolution. And now your sample resolution would be again in bits. I'm again and again referring to bits because usually students miss this part of multiplication by 8, जो कि बहुत important है. So it's basically multiply by sample resolution in bits, and finally you need to multiply it with the length of sample. And this length of sample has to be in seconds. So अगर आपको वो question में बोले of 2 minutes, तो do ensure that you multiply it with multiply 60 with 2. So like you use the value 120. ऐसा ना हो कि आप गलती से ना 2 ही लिख कर आ जाओ, you're going to lose marks. And one other important point here to note is that usually students believe that multiplying by 8, क्योंकि ये हर दफा होता है, it's part of the question, but it's not. It's basically when I multiply this with 8 up here, it's because I need to give the answer in bits. But let's say if I did not multiply this answer with 8, I would have received this answer to be in bytes, right? So फिर मुझे यहाँ पे divided by 8 ना करना पड़ता, because my answer would have been already in terms of bytes, and then I could have divided that with 1000 to get into kilobytes and then to megabytes. So with that, we have basically discussed the formulas related to calculating file size, and we are officially done with chapter number 1.32. Alhamdulillah. We would be looking into some questions, past paper questions, inshallah, in the next class regarding the calculation, and would be ending the topic with discussion of data compression, hota kya, and all those strategies used, inshallah. I hope we complete it. And with that, we would be officially done with the whole of topic number 1. Now, before ending the class, this conversion is, oh, don't worry. For now, just get this concept. Don't worry. This can just understand the formula. Formula mein kya ho raha hai? Inshallah, in the next class, we're going to do enough questions to make sure that you do not feel this concept to be difficult at all. I do understand this conversion part is a bit challenging when you study it for the first time, but remember, it's always going to improve, because when you start practicing, you're going to see a few questions and you would be like, okay, sir, ye to nahi mushkil, it's pretty straightforward. So for now, just today, ke liye, just understand that we're going to learn calculating file size, and we would be using this formula, the one which I mentioned up here. So we're going to be using this formula, this one, and then we would be using this formula. ये दो equations हमने use करनी है. हाँ, कैसे use करनी है? That is something we will be again looking into in the Monday's class, inshallah. So once we discuss it there, आपको अच्छे से सारा clear हो जाएगा. You don't need to worry at all. सब good scene रहेगा, okay? So for now, just memorize the formula, inshallah. And once we do like 5-6 past paper questions, you're gonna see sir इतना मुश्किल नहीं है. And I would be giving you guys sample questions जो आप लोग inshallah during class ही solve करोगे, and you're gonna understand that okay, ये तो easy peasy scene है. It's not that difficult, inshallah. So with that, it's 9:59. Do you have any question regarding anything which you might not have understood in this whole discussion? All right, perfect. That's great to know. Chalo, that's all for today. I'm ending the recording. If you don't have any questions, you can leave. Okay, Allah Hafiz.